Lesson 2.7 is your first introduction to trigonometry, and we'll look at right triangle trigonometry in this lesson. All right, so what is trigonometry? So you see it's from the Greek words meaning triangle and measure. So we use trig to find missing angle measures or side lengths in a right triangle. Okay, we are studying right triangles specifically. The functions, the trig functions, the sine of an angle, abbreviated SIN, and we use the Greek letter theta to represent an unknown angle measure. The cosine of an angle, abbreviated COS, cosine of theta. And lastly, the tangent of an angle, and that's abbreviated the tangent of theta. Okay, so we never write the full name out. We always use the abbreviation, but it is not sin of theta or cos of theta. Sine, cosine, and tangent. Okay, the three sides of a right triangle have specific names relative to a given angle. Okay, and we'll work on this. But we should all know, we know the hypotenuse is always the longest length in a right triangle. And we also know that it's always opposite of the 90-degree angle. So the hypotenuse is always the hypotenuse. Okay, the hypotenuse will never be the opposite or adjacent side to the non-right angle. So the opposite side is, as it would suggest, across from the marked angle. And then lastly, adjacent is the side next to the marked angle. Okay, so again, it's all about the placement of these side lengths, not the hypotenuse, but the opposite and adjacent sides are always relative to a marked angle in the triangle. So let's look at an example of that. Okay, so here in the first triangle, here's my angle X. Well, I know my hypotenuse is always opposite the 90-degree angle. Now from my angle X here, the adjacent side is the side that shares a vertex with the marked angle. It's the side right next to the marked angle. So then if this is my angle, opposite of that angle, okay, is the side across from the marked angle. Now, no matter where theta is, hypotenuse never changes. Okay, but now here, if theta is in this top left corner, this would now be the adjacent side to the angle next to the marked angle, or excuse me, the side next to the marked angle. And then this side length, this leg, would be the side opposite of the marked angle. So it depends on where the angle is, where the opposite and adjacent side will be. Okay, so just looking at any right triangle, name the hypotenuse. The hypotenuse is segment EF. Name the side opposite of angle F. So if this is angle F, the side opposite of angle F in the triangle would be the leg ED. The side adjacent to angle F, the side next to angle F would be DF. Okay, and then if I change the placement of the marked angle, so now if I look at E, the side opposite of angle E is now DF, and the side adjacent to or next to angle E would be the side DE. Okay, so now the trig ratios that we will use are the ratios for the sine of the angle measure, the cosine of the angle measure, the tangent of the angle measure. And recall what a ratio is. A ratio is one side length to another side length in the triangle, and we can represent ratios as fractions. So the sine of the marked angle is the ratio of the opposite side to the hypotenuse. The cosine of the marked angle is the ratio of the adjacent side to the hypotenuse, and the tangent of the marked angle is the ratio of the opposite side to the marked angle to the adjacent side. We remember this, the little mnemonic device, SOHCAHTOA. Okay, sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent. One thing that I need to point out, an angle measure always follows a trig function. Okay, so you always need the marked angle because from the marked angle we're able to identify the opposite and adjacent sides of the triangle. So an angle measure always follows a trig function. All right, so let's use these trig ratios. Okay, use the triangle to find the indicated trig ratio. So here I am at angle C. So I'm going to make this color coordinated. So I'll put angle C in blue. So from angle C, 24 is the opposite side, 7 is the adjacent side, and we know that the hypotenuse never changes. Okay, so it doesn't matter if we're looking at sine, cosine, tangent, where the marked angle is, the hypotenuse is always opposite the 90-degree angle. So let's take care of all things angle C. So the sine of angle C, the trig ratio for sine is opposite side to the hypotenuse of the triangle. So from C, the opposite side has a length of 24 and the hypotenuse has a length of 25. Get rid of that. Okay, so skipping down to the cosine of C. So the cosine ratio is the adjacent side to the angle to the hypotenuse. So from angle C, the adjacent side has a length of 7, the hypotenuse has a length of 25. And then lastly, the tangent of angle C, the tangent ratio is opposite side to adjacent side. So opposite of angle C is a length of 24, adjacent to angle C is a length of 7. All right, so now switching gears and looking at angle T here. So now from angle T, 24 is the adjacent side and 7 is the opposite side. Okay, so we've already looked at those relationships. The ratios don't change though. The tangent will always be the opposite side over the adjacent side. So here's angle T. Opposite side has a length of 7. Adjacent side has a length of 24. From angle T, the side opposite of angle T has a length of 7. We know the hypotenuse is 25. And then lastly, the cosine of T is the adjacent side to the hypotenuse. So angle T, the adjacent side has a length of 24 and the hypotenuse is 25. And we'll finish there for today.